Today in lesson 5.7, we're going to look at systems of linear inequalities. Now, as a quick review, when we see the word systems, how many inequalities are we going to be dealing with? Two. Okay, remember systems of equations, we had two equations, we graphed them on the same coordinate plane, and we found the point of intersection. So today we're going to look at systems of linear inequalities. Now, last night you learned how to graph an inequality. So today we're going to graph two inequalities on the same graph, and we're going to figure out the solution to that system. Now go ahead and open up Desmos on your phone, okay? Lay it flat on your desk so that you're not doing anything else on it. Open Desmos. If you don't have the app, remember Desmos.com through your internet server. You should be able to get to the graph just as easily, okay? Now, before we plug anything into Desmos though, let's look at telling whether the ordered pair is the solution of the system. Now, I threw a couple of these on your test Wednesday because I was trying to give you a couple of give-me's, and hopefully you got them, all right? But remember, when we're checking to see if it's a solution, does it have to make one of the inequalities true, or does it have to make both of the inequalities true to be a solution of the system? Both, okay? So as soon as it doesn't make one of them true, we can move on because we know it's not a solution. But let's look at letter A. Okay? Remember, in an ordered pair, we've got the x coordinate and we've got the y coordinate. So in this very first inequality, what are we going to plug in place of y? 5. And then we bring down the rest of the problem, which is less than 5. So when we read that inequality, 5 is less than 5, is that a true statement? No. So is there any need for us to plug the point into the second inequality? No. If it doesn't make them both true, it's not a solution. So our final answer is no. So the only thing I have to see is that you plugged 5 in and we see that 5 is not less than 5. So no, it's not a solution. All right, letter B. What are we plugging? We're going to plug the point into the first inequality. What are we plugging in place of y? Class? 4 is greater than or equal to 3 times. What are we plugging in place of x? 1 plus 1. 4 is greater than or equal to, class, what's 3 times 1? And 3 plus 1. 4. Is 4 greater than or equal to 4? Yes, so we're going to keep going. All right, we can't say yes yet. It made the first one true, but it's got to make the second one true. So the second inequality, what am I plugging in place of y? 4 is greater than, class, what am I plugging in place of x? Minus 1. What is 1 minus 1? Class, what's 1 minus 1? 0. So is 4 greater than 0? Yes. Since the ordered pair makes both inequalities true, is it a solution to the system? Yes. So our final answer is yes. All right, that's all you have to do. When you're checking to tell if it's a solution, you're plugging it into the inequalities. Now, the essential question for today: how can you graph a system of linear inequalities? And you have been introduced to the wonderful world of Desmos, so that's your first step. You're going to plug your inequalities into Desmos, exactly like you did last night, except instead of just one, you're going to plug in 2 on the same graph. You're going to copy it onto graph paper. Now, this is where you've got to be very, very careful. You have to pay attention to the solid or the dotted line. When should, Kyan, your line be solid? And this is a review from what you learned last night. So let's see what you learned last night. When will my line be solid? What will the symbol look like?
Greater than.
Just greater than?
Equal to.
Greater than or equal to, or less than or equal to. Very good. If your equation on your paper, your inequality on your paper has greater than or equal to or less than or equal to, and your Desmos graph has a dotted line, you've done something wrong. You've plugged it in wrong. So be very careful, okay? Your line should be solid if your symbol is greater than or equal to or less than or equal to. Which means, Blake, when will my line be dotted? Good. If it's just greater than or just less than, that's when our line is going to be dotted, dashed, however you want to say it. Okay? But again, you got to pay attention. If the equation or the inequality is just greater than or less than, your line should be dotted. Now, this is the next piece you've got to pay really close attention to. All right, the shading mattered, and I hope you picked up on that in my lesson last night, okay? It was one of the things in the notes. It said pay attention to the line and the shading, okay? With inequalities, there's more than one answer. See, when we were graphing equations or we were graphing systems of equations, there was a point of intersection. So there was one answer. But when you're graphing an inequality, there's a lot of different points you can plug in to make a true statement. So that's what the shading was showing you. It was showing you where all of your possible answers were falling or where they were on the graph. Okay, so if you did not shade in the lesson last night, when I come around in a few minutes and check, I'm going to make you go back and shade. The shading is part of graphing. Okay, where are all the solutions to your line? That's what the shading tells us. So in a system, the shading is even more important because where is the solution to your system? There's going to be a lot of different points. So the shading will be where the two sets of shading intersect. Okay, and I'm going to say that again. When I have a line, when I graph a line, there's going to be shading. When I graph a second line, there's going to be shading. Where do the shadings overlap? That's what I'm transferring onto my graph. Okay, so the shading, where they intersect, is what I'm going to bring down onto my graph. And we'll look at it here in just a minute. All right, so let's look at example number 2. So go ahead and plug letter A. You've got Desmos open on your phone. Go ahead and work on letter A, okay? Plug the first inequality, y is greater than or equal to negative x plus 4. And then plug in x plus y is less than or equal to 0. All right, and let's see what you get. Transfer your graph onto your graph paper, okay? Then once you've got letter A transferred, then do letter B. All right, but you want to do the two from letter A together. Draw them on your graph paper. Then put the two from letter B and copy those on your graph paper. And we're going to look at them here together in just a second. All right, so for letter B, the first inequality that we are supposed to be plugging in is negative 2x plus y. And it is less than 4. Okay, so just less than 4. So we can see on Desmos that we've got what kind of a line? No, what kind of a line? Is it dotted or is it solid? Dotted. Okay, it is dotted. And when you're picking points, when you're transferring it onto your graph paper, you've got a point right here at 0, 4. You've got a point at negative 2, 0. And you've got a point at negative 1, positive 2. So there's 3 points you can very easily find and transfer onto your graph paper. Okay? The line is dotted. Now, you'll notice the shading. Don't do anything with the shading yet because remember, it's a system. So we've got to find both lines. We've got to graph both lines and then find where the shading overlaps. All right? So for the second equation, we're going to plug in 2x plus y is greater than 4. All right, so there's our blue line. And again, let's find some points. We've got this point again at 0, 4 that we can use. We've got a point down here at 2, 0 we can use, and we've got one at negative 1, 6 we can use if we want to. Okay? Or you've got one at 1, 2 you can use as well. But again, notice how I'm finding actual points on the line, and that's what I'm transferring onto my graph. All right? Now, the shading for this one, did it go above the line or did it go below the line? Okay, let me take off the red line for a second. There's the blue line all by itself. Is the shading above the line or below the line? Above it, okay. Put the red line, take the blue line away. See where the red line shading was? So the question you're asking yourself is, where do the two sets of shading intersect? And you hopefully notice you've got a light blue here, you've got a red down here, and you've got a dark purple right here. So we are only going to put on our graph where the shading overlap each other. So are they overlapping in the blue section Are they overlapping down here in the red section, or are they overlapping over here in the, what I'm calling dark purple section? All right, so the only thing you're bringing onto your graph is this right here, okay, this section right here. So that's where Desmos, and you copying from Desmos, you're going to have to be very, very careful. All right, so go ahead and get just the piece where the shading overlaps. All right, so here are the graphs. Again, letter A, we're 2 parallel lines. So we've got no point of intersection. We've got no solution. And we're going to write that down. Since there is no solution, we're actually going to write down underneath or by that graph somewhere, no solution. Because there isn't one. Now, the graph for letter B speaks for itself, all right? And remember, in Desmos, I've got a picture of what it looks like in Desmos. On your graph, remember, you are only shading in this portion of the graph, okay? Because this is where your 2 sections of shading overlap. So that is where the solution to your system is actually going to be. All right, any questions? All right, awesome. Now, the last thing I'm asking you to do in this lesson is write a system of linear inequalities represented by the graph. So let's look at, and let's start on letter A with the easy one first, all right? Which line is going to be easier to find the equation for? The vertical line or the slanted line? Okay, the vertical line, right here. Because I know that this line passes through which axis? So x, and it passes through what value on the x-axis? 3. So I know I've got an x and I know I've got a 3 in my inequality. The only thing left for me to decide is my symbol greater than, less than, greater than or equal to, or less than or equal to. So greater than, less than, greater than or equal to, less than or equal to. Now, based on the line, which of these 2 symbols can I quickly eliminate? The or equal to lines, right? Because I know my line is dotted, so I know my symbol is not going to be greater than or equal to or less than or equal to. Now, the only thing left for me to decide is x less than 3 or is x greater than 3. So LJ, looking at the line, where is the shading? Is the shading to the left or is the shading to the right? To the left. So does that mean all my x values are less than 3 or greater than 3? Less than. So my symbol for the first inequality is less than. So x is less than 3. I've got the first inequality written. Now, the second inequality is going to take a little bit more work because it is slanted. So I'm going to find my m and I'm going to find my b. And then I'm going to plug it into y equals mx plus b. And then we can make our changes to the equal sign. All right? Which of those things have we learned to find first? The m or the b? The slope or the y-intercept? The b. The y-intercept. So, Paris, what is the y-intercept? And again, we're looking at this line right here this time. So what is the y-intercept? I don't know. You don't know where the line crosses the y-axis?
Oh. 2.
2. Perfect. So my b is 2. Now, from that point, I'm going to rise and I'm going to run until I hit another point. So, Paris, do you want to go down or do you want to go up first? Okay, so I'm going to go down. Do I need to go down more than one spot?
Yes.
Well, am I already lined up? If I go down 1, am I already lined up with another point on the line?
Yes, ma'am.
So then going down 1 is plenty. I went down 1. So is that plus 1 or minus 1? If I went down.
Minus 1?
It's a negative. All right, then from there, I'm going to go right or I'm going to go left?
Right.
Right. And how many spaces to the right did I go?
1.
I went right, so is that positive 1 or negative 1?
Positive 1.
Good. So Cam, based on my rise and my run, what is the slope of this line? Be careful, not 1, 1. Good. The rise is negative 1. The run is positive 1. So what's another way we could write this? What's negative 1 divided by 1? Negative 1. Awesome. Okay, so let's plug that into y equals mx plus b. So y equals Joseph. Awesome. Now, I'm going to bring this down here, but instead of bringing the equal sign, I'm going to leave a space because I know at this point we've got to figure out greater than, less than, greater than or equal to, less than or equal to. Now, Andrew, again, looking at the line itself, which of these two symbols can I eliminate rather quickly? The or equal to. Because again, my line is dotted, so I know it's either just greater than or just less than. All right? Andrew, again, the shading, is the shading above the line or is the shading below the line? Below. Does that tell me less than or greater than? Let it be obvious, okay? Above, if I'm above something, I'm greater. If I'm below something, I'm less. So if the shading is below the line or to the left of the line, what is that? That's less than. Very good. So the symbol in my second inequality is also less than. And this is my final answer. This is my system of inequalities. Okay? Now, I want you and your partner to work on letter B. All right? Take a minute, work letter B with your partner. All right, let's look at we'll go with our horizontal line first. Okay, our horizontal line first. So, Blake, Erdman, what did you guys come up with for the inequality for that horizontal line? All right, you said y is less than what? 2? 3. All right, let's break it down. Let's check. First of all, we know that horizontal lines do cut through the y-axis, so y is the correct variable. We do see that it is cutting through the y-axis at 3, so 3 is the correct value. And the shading is below the line, which is less than, and it's just less than because the line is dotted, so that is perfect. How many of you got y is less than 3 for that first line? Okay, awesome. Runye. I want you to talk to me about the vertical line. All right, the vertical line. What did y'all's vertical line inequality look like? All right, it crosses the x-axis at -1. So you had an x and a -1. All right, what about your symbol? Okay, it's a or equal to. Good. Is it greater than or equal to or less than or equal to -1? All right, why greater than? Good, the shading's to the right. So all my values are getting larger as they go to the right. So y is less than 3 and x is greater than or equal to -1 would be the system of inequalities. And that is lesson 5.7.